Molar concentration. Molar concentration is the number of moles of solute that can dissolve in 1 liter of solution. Molar concentration is often referred to as molarity. So keyword here is molarity. So in other words, this title could have been called molarity. So molarity is moles per liter solution. Okay, we haven't looked at moles, okay, in a while. We've been looking at mass, we've been looking at volume, parts per million, parts per billion. Now we're actually going to revisit the number of moles. Okay? So remember the following pyramid. Molar mass is equal to mass over the number of moles. So that's going to be very important. So molarity, moles per liter, is equal to amount of solute in moles divided by volume of solution. Now, remember when we were looking at those concentrations, the concentration units were always in milliliters. Look at what the units are for volume, liters. So make sure you remember the differences. Another way to refer to this as in a simpler equation is concentration, okay, or molarity, C, is equal to the number of moles, okay, of our solute divided by the volume of the solution. Okay, that's the simpler way of rewriting that equation. So let's look at the first sample problem. A saline solution contains 0.90 grams of sodium chloride, NaCl, dissolved in 100 milliliters of solution. What is the molar concentration of the solution? So, we know that the molarity, okay, or the molar concentration, is equal to the number of moles divided by volume of the solution. Now, our number of moles, do we have that? We have a periodic table, right? So we can convert our mass into the number of moles. So what do we need to find? Molar mass of NaCl. Okay, so due to time constraints, 0.90 grams divided by the molar mass of NaCl is 58.44 grams per mole. Grams cancel out, and we're given 1.54 times 10 power of negative 2 moles of NaCl. Okay. So we have that number of moles of NaCl, and that will be this. Our volume of the solution, 100 milliliters, but we can't just use that because we first need to convert it to liters. So 100 milliliters is equal to 0.1 liters. So we put that in there. So a molar concentration is 1.54 times 10 to the negative 2 moles divided by 0.1 liters. So when we divide the two, we get 0.15 moles per liter. But least number of significant digits in my question is 1. So my answer is 0.2 moles per liter. So 0.2 moles per liter is the molar concentration of the saline solution. Last sample problem. At 20 degrees Celsius, a saturated solution of calcium sulfate, CaSO4, has a concentration of 0.0153 moles per liter. A student takes 65 milliliters of the solution and evaporates it. What mass in grams is left over in the evaporating dish? All right? So molar concentration is equal to number of moles over volume. So, 0.153 moles per liter is, which one of those letters? A C, right? So we've got 0.0153 moles per liter equals. Do we have number of moles? No, we don't. So we don't have the number of moles. Do we have volume? Yes, 65 milliliters. Can I just write that in? No, I got to convert that to liters, which is 0.065 liters. So we want to isolate for N, the number of moles. And we bring this over. So we get 0.0153 moles per liter times 0.065 liters. Liters cancel out, and I'm left with 9.94 times 10 to the power of -4 moles. So that's how many moles, okay, that I have, that I've been able to extract from this this solution. Now I want to find the mass. To do that, what do I do? Exactly. I find my molar mass of calcium sulfate, right, in solution. So we take the molar mass calcium sulfate, and we're going to multiply it by that. So molar mass. Okay. The molar mass of calcium sulfate is 136.15 grams per mole. So we have 9.94 times 10 to the -4 moles, and we're going to multiply it by 136.15 grams per mole. Moles cancel out, and the volume that the mass that I'm left with is 0.135 grams. But the least number of significant digits in my question is 2, so my answer is 0.14 grams is left over in my evaporating dish.